We have a special version of the mean value theorem for integration. This says if f is continuous on the closed interval from a to b, then there exists a number of c in the closed interval from a to b such that the integral from a to b of f of x with respect to x is equal to f of c times b minus a. So this is actually the same, or it's actually equivalent to the mean value theorem for derivatives that we learned. If you consider a capital F where f prime of x is equal to little f of x, then the integral from a to b of little f of x dx would be f of b minus f of a. Okay? And we know that if we set that f of b minus f of a equal to the version we have over here, little f of c times b minus a. And then if I were to divide both sides by b minus a, I would get that little f of c is equal to f of b minus f of a over b minus a. And we know that capital F prime of c is equal to f of c. So we're basically saying there is some c such that this is true. And if you look at this and replace the capital F's with just a little f, it would be completely equivalent to the intermediate or the mean value theorem that we looked at for derivatives. So it's equivalent, it's just in a different form. Now if you want to think about this geometrically or graphically, if you look at this shape right here, basically what we're saying is there's some value c between a and b such that if you form the rectangle at the height of f of c, right here, this blue rectangle has the same area as this pink shape right here. So basically we're saying there's some point where if we just want to find the area of a rectangle, we could find the area of the whole shape using that rectangle. So that's the integration or summation version of the mean value theorem. Now the value of f of c that's given in the mean value theorem for integrals is called the average value of the function on the integral or on the interval from a to b. Now the thing about average value of a function, a lot of students will try to just add up as many of the function values as they can think of and then find the average of those numbers. But we don't actually want to do that. If we want to find the average value of a function, we want to use this formula here that we found because the thing about it is you've got infinitely many points there, so you're not going to get an accurate average by just adding up numbers and dividing them by however many there are. You have to actually use an infinite sum in order to get an accurate average. So basically, we're taking this f of b minus f of a and dividing it by b minus a, and that is just the definite integral from a to b. So that's all we're doing. So if you want to find that average value, that rectangle right there, or the height of that rectangle right there, that's what we're going to do. We're going to take the integral and then divide it by the width of the interval. So if you want to find the average value of f of x equals 4x cubed plus 7 on the interval from 2 to 5, the average value here would be equal to 1 over 5 minus 2 times the integral from 2 to 5 of 4x cubed plus 7 with respect to x. So this is 1/3, and then we're going to take the integral. So this will be 4x to the 4th over 4 plus 7x, and this is going to go from 2 to 5. So that'll be 1/3 times, this cancels, so we have x to the 4th plus 7x from 2 to 5. And you can either fold the 1/3 into it, or you can wait till the end. I think I'm just going to wait till the end. So this first part will be 5 to the 4th plus 7 times 5. And the second part will be 2 to the 4th plus 7 times 2. So that gives me 1/3 times 5 to the 4th is 625. 7 times 5 is 35. And then 2 to the 4th is 16, and 7 times 2 is 14. So if you add all these numbers up, you get 630, and 1/3 times 630 is 210. So the average value of this function on this interval is 210. So we're going to do another one of those. If I want to find the average value of f of x equals 5x squared on the interval from 1 to 3, the average value would be 1 over 3 minus 1 times the integral from 1 to 3 of 5x squared dx. So this will be 1/2. This one will be 5x cubed over 3, and we're going from 1 to 3. So we'll have 1/2, and in this case, since we've got so many numbers here, you could actually bring the 5/6 out if you want to, and make it the integral from 1 to 3 of x cubed. So I just multiplied the 1/2 times the 5/3. So this will be 3 cubed minus 1 cubed, which is going to be 5/6 times 27 minus 1, or 5/6 times 26, which is 65 over 3. So that would be my answer there.